cube satellite, right? So let me share my screen. Okay, so I hope my screen is visible, right? Abid, can you confirm?
Yes, 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 yes.
Oh, so I divided this session in a 12 segment. Okay, so first we will talk about the introduction. So what is a CubeSat? Right. So from the name we can understand that CubeSat is a satellite because it have two prefix and suffix, right? One is cube and second one is sat. So cube means it is a structure which is divided into a eight sides, right? So it will be a cube, and sat means it is a satellite. So if we think about the size of the CubeSat, so it comes different size. So there is one U CubeSat. One U CubeSat means it have 10 centimeter by 10 centimeter a cube, right? And there comes two U CubeSat means 10 by 20 centimeter. There comes three U CubeSat. In this slide, you can see that it is a three U CubeSat means 10 centimeter by 30 centimeter CubeSat. So, based on their size, uh, you can see that it is a bus, right? And here it is a small car. So, this small car can be compared with a 1U CubeSat. So, it is a very, very small size and very compact size compared to a larger satellite. And if you talk about the weight of a CubeSat, so the weight of a small satellite is like 1 kg to 500 kg. But in a CubeSat, it must be less than 1 kg. So for a CubeSat, the weight of a CubeSat it is less than 1 kg, means like 900 grams or 700 grams. Even the smallest CubeSat made by Rifat Saruk, who is a chief scientist of Space Kids India. You might you might heard the name of him. So he made the smallest CubeSat. It is weight around like 100 grams only, right? If I am not wrong. So this is the weight of a CubeSat. So next we have to understand that what is the purpose of CubeSat. Why we build a CubeSat? Because we have already a larger satellites which can work perfectly. So why it comes in CubeSat? So the primary mission of a CubeSat to provide access to space for small payloads. Like you just want to organize an experiment for a particular one segment. Like you just want to measure temperature and humidity for upper atmosphere of the Earth, right? So for that you need not to build a larger satellite. You just want to build a smaller satellite for a smaller scale of experiment, right? And the purpose of CubeSat is to provide a standard design of nanosatellite to reduce cost and development time and increase the accessibility of to space, right? So, like some of you might have think that if I want to build a satellite, it must be cost around like if I don't want to tell the figure, but it will cost around $1,000, right? Sorry, $100,000. So if you want to reduce the cost and if you want to send an experiment to space, then you will need a CubeSat. It will cost maximum around like $100 maximum. Sorry, minimum $100 and maximum it will go up to $1,000. Right? Means if I talk in INR, so it will go up to 80 to 90,000 rupees maximum. So the CubeSat standard is being used to develop pico satellites for high school, universities, government agencies, and private companies. Right. So the main use of CubeSat, it is mainly used by schools, students, then university students, then researchers, and then who want to make a particular experiment or want to their for their research field. So they particularly use cube satellites. Now if you you can think that what might comes under the CubeSat, like what kind of sensors it have, what kind of particular structure it have, right? So if I compare a CubeSat with a mobile phone, right, a mobile phone have a antenna, right? You can't see the antenna, but inside the mobile phone it have an antenna to receive and send data, like so, and it have a sensors. Now mi phones or redmi phones have IR burst, right? So you can control TV, AC, and projectors using a phone, right? And a phone have an interface. Like if you want to show some data, or if you want to view some visualize some data, then you might have some interface. You should have an interface, right? Then then a mobile phone have a communication system, right? You have a SIM card, and using that SIM card GSM module, you can call anyone, you can send message to anyone, right? You can receive message, you can receive calls. Then a mobile phone should have a battery, because without power supply, no electronics device can work, right? So it should have a power system, and if it have a power system, it can't power a device for infinite time, right? So it should have a charging system to charge it, to run it for a lifetime, right? So a mobile phone have a charging system also, and a mobile phone have a camera. Nowadays every mobile phone, every smartphone have a camera, right? And it have a massive computing, because without a processor, without a proper uh, processing power, any good electronic device can't work, right? So it should have a massive computing, or a microcontroller or a microprocessor, right? So now the next slide, you can see that it is a cube satellite, inside of a cube satellite, right? So inside of a cube satellite, it have a several components, or you can say several subsystems, right? So firstly, it comes here comes UHF monopole antenna, right? So a cube satellite, inside a cube satellite, there are two types of antenna. One is UHF, and second one is VHF. So UHF mean ultra high frequency, and VHF means very high frequency. Okay. So most of the CubeSat use ultra high frequency, because if you want to send a CubeSat to a LEO, mean low Earth orbit, then you should have a UHF antenna. So this antenna have a particular frequency range between 433 to 438 megahertz. Okay, and a frequency bandwidth of 25 kilohertz. And this antenna will send the data that is gathered by different sensors. Okay, so it will send that data back to the ground station. Okay, that is called downlink. Okay, and if you want to send a particular comment to this CubeSat, if you want to know the location, okay, so you send a particular comment from the ground station to the uh, satellite. So it called uplink. Okay, so the next comes the main board. Okay, so this main board is a particular PCB board which contains the microcontroller and the other components, like other sensors, and this is the main subsystem of the cube satellite. And also it connects with the antenna, right? So that it can send the data to the antenna, and then the antenna means the transmitter system can send data back to the earth. Okay, And then comes the hysteresis place. It provides the, I will share the PPT and as well as the images to Abhi. He will share with you. So next come the hysteresis plate. It provides the rotation damping around the satellite. Okay. So if you want to visualize the satellite's rotation or the gyroscopic data, right, from the Earth, you don't know that the uh, satellite is moving to which direction, the satellite is rotating to which direction, right? You don't know. That's why in that case you have to use MPU 6050 sensor. So using MPU 6050 sensor, you will get the acceleration and the gyroscopic data back to the your ground station, and using that data you can easily visualize that in which motion and in which direction the CubeSat is moving in XYZ direction, okay, axis. So then comes the battery. As you know that any electronic device works on a particular power module, right? So you should have some power system to power the CubeSat. So in that case, we will use lithium polymer cells, which is highly efficient batteries and especially used for small electronics like cube satellite or CanSat, etc. Then comes its S-band transmitter. As I said you that if you want to send some data back to Earth, you should have a transmitter, because this transmitter will send the data to the ground station, right? So this S-band transmitter provide 1.06 Mbps user data rate and 5 watt input power. Okay, so the data rate is 1 megabyte per second, right? So easily you can send a small amount of data to the Earth. Okay, then comes camera module. Camera modules, like a satellite is rotating around the Earth, right? So if you want to observe the Earth, or if you can you want to click pictures of the Earth in that particular position of the satellite, so in that case you need a, obviously we will need a camera module, right? So this camera module can click a picture on a resolution of 640 to so 1080 megapixel. Okay, and this image pixel size is 640 into 480 pixel, so you can get a clear picture of Earth. Then comes a permanent magnets. Yeah, so these permanent magnets, you one CubeSat must have a permanent magnet because it aligns the satellite position with the Earth's magnetic field. Okay, and then comes the S-band patch antenna. As I said that this patch antenna sends the data to the and the main monopole antenna, and that antenna sends the data to the ground station. Then comes the sun sensor. You can add a sun sensor, or you can also not add a sun sensor. It is not a mandatory. But then comes the solar board. Okay, so as you know that a battery can power a cube satellite up to a certain time, right? After that the battery will die. So how can we charge the battery? For that we need a solar cell. This solar cell, like this, when the sunlight falls into the solar cell, it will charge and it will charge the battery on a particular time, right? Because when the cube satellite goes the backside of the Earth, when the sunlight is not not falling into the CubeSat, then the battery will work, right? And when the CubeSat comes in front of the Earth, then the solar cell will charge and it will charge the battery as well. This is the whole inside structure of the CubeSat. Then comes the outer structure. Because in space there is a several temperature uh, 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 variation, right? Because sometimes it will get too cold and sometimes it will get too hot. When it comes in front of the sun, then it will the temperature will be too hot, right? And when it will go backside of the Earth, when sunlight is not falling into the falling into it directly, then the temperature will be too cold. So you have to choose the material such a way that it can survive for the both position. Right? So the most commonly used material in CubeSat structure is aluminium. So before you send the CubeSat up to in the space, you have to your CubeSat should go undergo a vibration analysis or structural analysis to ensure that the components is inside the CubeSat is supported or unsupported by the uh, P-pod by the peapod. Yeah. So what is the peapod? The peapod is the inner platform of the CubeSat where the sensor or CubeSat are held. Right. So so inside when you put the CubeSat inside the rocket, there is a huge vibration when it will during the launching time. Right. So maybe some case it will disconnect it from the upper platform. Right, or it can be maybe disconnected from the battery or the power source. So you have to put your CubeSat to some such kind of experiment when you can understand that yes, my CubeSat is now ready for the launch. Right. Now comes the antenna. As I said that there are several types of antenna like monopole, bipole antenna, and there is a particular frequency range which is used for that particular antenna, right? Like 435 to 438 megahertz frequency bandwidth. We will use that frequency bandwidth antenna for CubeSat. So yes, there are several kind radio frequency wave we can use for CubeSat like VHF, very high frequency, then UHF, ultra high frequency, then L, S, C, and X band. But mostly use VHF and UHF. Then then we comes to the part of power, right? So for powering a CubeSat, we need a battery, right? Lithium cell battery. And to charge that particular lithium cell battery, we need solar cells. And these solar cells are not regular solar cells. These solar cells are highly efficient solar cells, and you can't buy the solar cell from a local market or somewhere. You have to order it via online, and only a few companies provide these kind of solar cells, which is still satellites. And one more thing, like if you want to put a cube satellite inside a rocket, so what? You might have a question that up to a particular height, when the rockets hatch opens, and then how can the CubeSat uh, like get outside from the rocket? So there are several deployers. Like you might heard the name of Dhruva Space from India. They in the early stage they built that kind of deployers. Inside the deployers, the CubeSat will be placed, and when the particular altitude, when the rocket hatch opens means the sunlight is directly falling into the deployer, and there is a solar sunlight, or you can say that sun sensor there are placed. So when the sunlight falls into that particular sensors, it will trigger, and the hatch of of the deployer will open, and the CubeSat will be thrown outside of that particular deployer. Okay. So after that particular height, if some case like a rocket will go a particular height, and it will attain a at a desired orbit, right? But in some case, the rocket will slightly get down by a 1 or 2 kilometer, or it will not get your particular orbit, right? In that particular case, you should have a propulsion system on a CubeSat to attain that particular orbit, right? So for that, we use mostly we use chemical propulsion, right? But right now, a lots of companies is on researching on cold gas propulsion, then electronic propulsion and solar cells, right? Then comes one of the most important part, that is computing. Like larger satellites, cube satellites must have a computing system, right? If we talk about a microprocessor, so which is the brain of a CubeSat. So every sensor around the microprocessor will send the particular parameter data, like a PMP 180, which can measure temperature and altitude, right? So it can measure that particular temperature and altitude and send the data back to the microprocessor. Okay, then comes DHT11, which can measure humidity. It will send the data back to the microprocessor. Okay, so like that, every data which comes from every different sensors gathered into the microprocessor. Now the microprocessor process that data and convert it to a text format. Okay, so there is a huge computing inside the microprocessor. I will not talk about that today. So that data or that parameter of that which comes into the microprocessor, from the microprocessor, that data after processing it will goes into the transmitter. Then the transmitter sends the data back to the earth. Right. Now comes the most like important thing, that is launch, because launching CubeSat is not easy, particularly in India, like a developing nation in India. Like if you want to build a CubeSat satellite, it will cost around 50 to 60,000. If you do a very cost effective things, you can buy components from a company or something, or some manufacturer. So if you build a cube satellite under 50,000 or under 60,000, then it is very good. Okay, but then comes the most challenging part, that is launching, because without launching, that CubeSat is no use, right? You can't like, if you want to build a cube satellite, then you might have a purpose, that I want to measure some data, or I want to perform some experiment on a upper atmosphere, right? So you have to launch it. So for launching, there are two options. One is high altitude helium balloon launch, and second one is rocket launch. So for high altitude helium balloon launch, it will work like, you have a balloon which can uh, inside the balloon there is helium gas. Okay, so helium gas is a uh, like, it is a I can say that it cost around like 7,000 to 10,000 rupees for the helium gas. Okay, so you need a two to 3 kg of helium gas inside the balloon, and then you have to attach a parachute.